Hi guys, I wanted to walk you through a Hardy Weinberg so you have a little bit extra guidance when you're doing your homework. So in this problem, the first thing I've done is to write out the equations, and then I have identified what the variables stand for. So just to review, P squared are going to be the individuals who are homozygous dominant. Q squared are the individuals that are homozygous recessive, and 2PQ are those that are heterozygous. So you see these are different, so hetero means different. These add up to 100. This other equation is looking at the gene pool. How many times you see the dominant allele, how many times you see the recessive allele, that should add up to 100 as well. So here we have our first problem. It says the population of dogs has extra toes. This is a recessive trait. 25% of them have the extra toes. So what we do is we always start with Hardy Weinberg with Q squared. That represents the organisms that are homozygous recessive. We can see them in a population. I could go to this population, which remember is always 100 in my world, and I could count how many dogs have extra toes, and I could see that it's 25. So you always start with Q squared equals 0.25, or whatever number I have given you. The next step is to go from dogs, from the individuals, to the gene pool to look at just the allele. Because this is the recessive allele, and some of them are hidden over here. So the way you do this is to go from Q squared to regular Q by taking the square root of Q squared. So you can put 0.25 and the square root button on your calculator, or you can say what number times itself equals 25. That would be 5. So 0.5 and then add a 0. There is always supposed to be 2 digits. So this means that even though there's only 25 dogs who have the recessive trait, the allele, the recessive allele, is found in half the population. Third, because these two variables must equal 100, if Q is already 50, then P also has to be 50 to equal 100. So P, the dominant allele, is 50%. Now I can use these to plug in for our last two variables. With P, you can go to P squared, so you multiply 0.50 times 0.50, and that equals 0.25, or 25%. So 25% of the dogs in this population are completely homozygous dominant. But we want to look at this one. These are the guys that show up dominant but hide a recessive, so they're very, very important. So you can plug things in, but I just use logic. So if this is 25%, and this is 25%, that's 50%, and I know it has to add up to 100. So this has to be 50 for these three to add up to 100%. So 2PQ is 50%. So now we can come down here and we can plug in these values. When we see just one lowercase letter, that is a recessive allele. The recessive allele over here is 50%. One uppercase letter is dominant allele. Dominant allele is 50%. Two lowercase letters is in a genotype of homozygous recessive. Homozygous recessive we were given as 25%. One capital, one lowercase is hetero, different, heterozygous. That is 50%. And two uppercase letters, homozygous dominant, that is 25%. So I hope this makes sense. I hope it helps you a little bit on your assignment. Let me know if you need any other help.